Little background, I was global electromechanical wireline sales manager for both Rochester and Mesa over the last 40 years. Now I'm very excited to be part of the Wire and Bytes team that is producing this next generation of downhole data acquisition cables, fiber optic slick lines. We partner with a UK company, SolarSense, to supply the complete system. Wires and Bytes supplies the fiber optic slick line, trade name SLICKLINES, and SolarSense provides the surface panels, connections from the unit drum to the surface panel, software programming specific to your desired information targets, downhole termination, and training on the operation of the system. Or if they don't do it, they connect you with one of their partners. So we get the whole system comes from just one place. It'll be through Wires and Bytes, and we'll coordinate everything. Your current slickline truck or skid unit does not have to be modified, with the only exception being from the drum to the connection to the panels. There is no connection that can rotate like it with a normal copper wire line. So the drum has to be still when you're connecting to the drum to the surface equipment. We start the presentation with our VP of Technology, Peter Basic, who will explain the construction and the characteristics of the fiber optic slick line. Peter's been working in the fiber optic field since 1998, concentrating on the fiber optic measurement and sensing since 2006. After Peter's presentation will be Mike Webster of SolarSense. He is their technical lead. Mike was with BP for most of his career and has extensive knowledge of conventional and fiber optic data acquisition. During the presentation, there's an option for you to submit questions through the WebEx, and we will have a question and answer session directly after the presentations. Presentation hopefully will last no longer than 1 hour. So Peter, please begin.
So, yes, this presentation is about slick lines, fiber optic slick lines. And actually, we will start explaining main advantages of fiber optic sensing technology in general. These benefits are actually spatial profiling, since we have, of course, thousands of measurement points along the cable. And then it is, of course, lightweight and small size, and very much fiber optic sensors are also considered as galvanic insensitive and electromagnetic free medium. So this is also very important in many applications. We already mentioned spatial profiling, and this is unique to fiber optic sensing. So for the spatial profiling, we are using backscattering effect in optical fibers. And actually, good example of this would be in our daily lives, driving at snowy night and snowflake reflections, which you can see from the car, especially when the long lights are on. Spatial profiling in optical fibers works exactly like that. We launch laser light pulses generated inside the instrumentation unit into optical fiber, and then we collect the light backscattering from the fiber along with their, of course, arrival time stamps. The backscatter is then converted back into the electrical signals, so from the cable. In the photo detector, it is then, of course, converted back into electrical signal, digitized, and saved as a file. Now, Knowing the velocity of light in the optical fiber, the backscatter magnitudes, together with the timestamps, all these are provided now in the files. We can relate each backscatter to the position along the fiber, and this is exactly how spatial profiling is provided. Of course, all these data are then further processed, visualized, and results are analyzed. Just as a two examples here about the spatial profiling. It is very often depicted in colorful graphics, like you can see here. So on the left side, for example, you can see impact of fluid injection on the temperature profile. And on the right side, acoustic blueprint of gas release. Yes, retrievable cables. We actually, along with fiber optic permanent installed cables, which stay in the well, of course, all fiber optic retrievable cables can be used for data acquisition as well. In that respect, there are two possibilities, the wireline and the SLICKLINE technology. Fiber optics are being integrated in both. Nevertheless, the fiber optic SLICKLINE might be preferable choice when DTS, so distributed temperature sensing, and DAS, distributed acoustic sensing, is the only or main operation to be done. In this presentation, actually, we will address fiber optic SLICKLINE. Yes, SLICKLINEs are, of course, small in size and circular in shape, and this can simplify equipment needed for the job. When lowered in the well, fiber optic SLICKLINE can remain static there. Acquisition over entire length of the SLICKLINE is fast. Well, in case of DTS, it means it shall take about 10 seconds. And in the case of DAS, it will be real time. The data can be already processed, visualized, and if good connection is provided, uploaded to the cloud already on the well side. Therefore, the decision can be made on the site or remotely. Please note that today also hybrid electrical fiber optic SLICKLINE is available too. So these are the products which Wise Advice produces and offers to the market. We have three types of them: fiber optic, like you can see in the top, hybrid one, which is in the middle, and heavy duty one, which is the last. To build these products, we use all those super alloys materials like Incoloy 825 steel in the outer encapsulation. And then we will be adding thick wall small OD encapsulation already in Q3 this year. Of course, we can further customize all of our designs. About the SLICKLINE unit, the SLICKLINE unit can host two reels, of course, and it is technically possible to deploy electromechanical SLICKLINE together with the fiber optic one on the same unit and still keep it separated and independent in the operation. Yes, how does connection between the instrumentation and SLICKLINE looks like? Well, these photos are showing that. The power reel hosts the SLICKLINE, and the high pressure seal termination box is inside the spool. So inside the box, the SLICKLINE is spliced to the connector, now mounted on the front plate or front side of the box. For the optical connection between the SLICKLINE and its instrumentation, small mobile spool with an access fiber optic cable is provided, which is this spool. And then the cable is stretched from termination box on one side, and on the other side it goes into these cabin or shelter, and then it is connected. The right procedure will be, of course, stretch the cable, secure it physically, and then connect. We work constantly on improvements and new designs. In February this year, we filed a patent on the SLICKLINE integrating high-temperature carbon fiber strands as ultra-light strength members inside the new SLICKLINE, which will be prototyping very likely this year. This design should offer trade-off between size, tensile strength, and also the weight. A little bit about our test facility in few slides. All designs are being tested in the test facility, of course. They are tested for temperature cycling. We have a tensile strength bench in which we actually check all the breaking strengths. And also, very recently, we added automated repeatable bend test bench to measure the bending number of bending cycles possible with each design. We do, of course, the cables aim for acoustics were particularly interesting topic in the last years. So we designed and built acoustic test bench, and we of course prototype several samples, and together with the partners and customers, which are all leaders in DAS technology, we conduct the acoustical testing on those prototypes. Along with that, from the optical side, we do have optical time domain reflectometers. We do have also Brillouin equipment to learn mechanical impacts on optical fiber performance. Also, the lab is equipped for electrical tests. For all those designs combining fiber optics and electric signaling and power delivery. So many such tests are actually customer specific. Just as a two final slides or three, this is a manufacturing facility in Russia where all downhole cables are being produced, SLICKLINES and also the wire lines. There is also manufacturing facility in Arlington, close to Texas, in Texas, close to Dallas, in which much of the telecommunication cables are being produced. And to summarize, for the data acquisition, fiber optic SLICKLINE technology, actually today its use is mature equipment available in the market. It provides the temperature and acoustic data. In the near future, we will be very likely the strain too. While SLICKLINE as a cable, it remains static in the well during the acquisition. This is the objective of Wires and Bytes. To further advance technology and add new features and also new SLICKLINE types in the near future. So this concludes my presentation. Thank you very much. And if you have questions, we will be answering them in a question and answer session. Now I will give my word to Mike Webster. Mike, please do take a lead.
Okay, thanks, Peter. And I've got the little magic ball that says I'm now the presenter, so hopefully I'll be able to share. Let's see if that works. Share. And share my slides. So hopefully you can see my slide pack. Give me a thumbs up, Peter, if the slide's coming through. Here we go, thumbs up from Croatia, excellent. That's what I like to see. Right, SolarSense, who are we and why do we exist? And it boiled down to SolarSense is made up of a number of folk that have spent quite a long time in the oil and gas industry. Certainly I've been in for the better part of 40 years, as have my fellow co-workers. Now, we've all had different specialities, and we've all worked extensively with surveillance, well interventions, and latterly in fibre. And we got very frustrated with the way fibre was being portrayed and presented to the industry. A lot of fibre tended to, especially the surface acquisition boxes, tended to come from the academics side of things or the military side of things, where it was very high-end stuff, and you needed a PhD in optics to understand some of this stuff. And for normal people in the oil field, it was just not particularly accessible. So we wanted to try and make it a lot easier to deploy, really simple acquisition systems and fast processing, and that was the basic thing that we were trying to achieve. And so we partnered with a number of providers for hardware and equipment. We developed our own software to try and overcome some of those barriers and hurdles to the widespread deployment of fibre within the well stock. And it should be a normal part of business, and really it wasn't, and that just wasn't acceptable. So we've clearly partnered with Wires and Bytes for the cable and the wire system, and you've just heard from Peter the rigor that they test and manufacture these products with, and also the developments that are coming down the pipeline in the near future. We also have a link with AP Sensing for the provision of the surface units, and also a company called Viavi for a small portable unit where that's appropriate. And then we've got a sister company, Well Conveyor, if you're running high angle horizontal wells and a tractor is required. So those are the general key alliances and partnerships that we have built over the last few years. We've also got the ability to plan and set up a job. Getting into this business is quite difficult if you have no background in it, and so we're very conscious that there's quite a bit of support required in terms of what equipment is appropriate, how is it set up, how do we gather this data, what do we tell the client in terms of what we want to do in the well to achieve their objectives, right the way through to the fast processing of the information itself. And we've all heard the big data problem with fibre, and some of the software applications were not exactly user friendly, and so we've tried to combat that. And towards the end of this presentation, I'll do a short demo with the software and just show you how easy it is to use. We've had to develop other things as well. So we've got a SLICKLINE rope socket that's a set down to release rope socket, and again that's available, although we could use conventional rope sockets, but that's again the sort of thing that we've had to think about. And then likewise, I mentioned the battery operated tractor. If we're using SLICKLINE, we don't want to be restricted by just the constraints of gravity when we get into the well. if we've got the ability to actually power down to the toe of the well, then that gives us quite an advantage. So for high angle horizontal wells where gravity is just not going to cut it, then we can put the battery tractor on the bottom as well, and achieve full length surveillance in the well. These are the specs, but again, if you look on the Well Conveyor website, you'll get more information. I mentioned the surface interrogation units. So we've got a DTS unit from AP Sensing, 12-kilometer range, which is long enough for most wells that we come across, with a spatial resolution of about 0.5 meter. So that's essentially when Petter was talking about chopping up the length of the fiber into manageable chunks, then that's what we're doing. We're taking up to 0.5 meter slices of information right way down the whole length of that fiber. Although we tend to work around about 1 meter to give us a bit better signal to noise. But if there's fine resolution required, then we can get down to 0.5 meter. And then likewise, in terms of refresh rate on the profiles, the thermal profiles that we're generating, then 10 seconds is the minimum, but it's kind of nice if we stack things and again, to achieve a good signal to noise. And so between 3 and 5 minutes is generally what we'd use. But this is all configurable. And then the acoustic unit, the DAS unit, again, 12 kilometers range, a slightly broader spatial resolution, 1.25 meters at its finest. And this is the unit that really generates the large volumes of data, and where historically there's been issues in getting access to that information and shipping it around to people that need to make decisions. And we'll see how we've overcome that issue with the system that we've got. So Petter actually had a slide where he showed some of the surface equipment. So other than the drum of wire on a standard winch unit, it's terminated with this little termination box inside the spool, and there's a little dual connector there where my cursor is, and we've got a surface wire that plugs directly into that to establish the connection with the wireline drum, and then the other end into the back of these units that are housed in Peli cases. For most people that are involved with production logging and have experience with production logging, then some of this, the size and the of the equipment is roughly the same as a Warrior type production logging spread that you would get. It's controlled via a laptop. So this whole system here is controlled via, it's more or less a standard laptop, and what we've done is we've moved towards standard gaming spec laptops where they've got a really good graphics card and they're readily available from any good, well, I guess gaming store or a computer store. So there's no fancy equipment required to drive these units at all. And again, I'm actually running this presentation off a gaming spec laptop, a 15-inch, 15.6-inch screen, and this is the machine that I actually use to process all my my fiber data on anyway. If portability is crucial, then we also have access to this Viavi small portable DTS system, and it's only temperature profiling it does, but it's a very, very small machine, 3.5 kilograms in weight. I've personally hand carried this to the fiber conference in Denver, a couple of years, but in fact, it was pre-COVID. It seems ages ago, but certainly I think if SageRider are on the call, then I think they were there and saw this unit in operation at Denver. But again, it can be controlled remotely as well, and the data can be recovered off it remotely if needed. So, and then of course you need a toolbox of equipment to keep the system healthy, and that's splicers and cleavers and various other bits and pieces, and we provide that too. So what we want to do is to try and help operators and service companies get the most out of their wells, and so the appropriate sequencing of events to diagnose specific problems is what we're interested in achieving here. Unlike normal slickline services and wireline services, where you've got a point sensor at the end of the wire or cable that's lowered down, we want to deploy the fiber as deep as possible in the well, and then lock it in place so it's stationary, and then acquire information over the whole length of that well and manipulate well conditions at surface. And that is particularly important for things like leak detection and for flow and flow assurance type problems. So I could, if I wanted to, bleed off or inject into annuli or the tubing and observe the response in the fiber in the well. And that's the power of the system, is that I don't need to know where the problem occurs. I'm going to let the well guide me. And so with control at the surface, and I think there's something like 60-70% of the well stock tends to have sustained casing pressure. So it's a very common issue. And so a lot of regulatory authorities are getting quite picky about that sort of issue. And so when it comes to license to operate and HSE issues or contamination of overburden groundwater sources, etc., these types of surveys are really particularly useful. And then likewise with well abandonment, pre-abandonment surveys for looking for identifying potential porous and permeable beds in the overburden. Again, we tend to drill wells down to the pay horizon as quickly as physically possible, and tend not to get that many logs over any porous and permeable beds in the overburden. And so, a lot of the time we're not exactly sure where potential issues are in the well, and this is where this technology really comes into its own. So the aim here is to gather the data, program the sequence of events, gather the data, provide software at the well site for somebody to process at the well site. So if an answer is required immediately, it can be provided. And if you have to get data to a decision maker in a remote location, that we can shrink the size of the files sufficient so that we can use conventional comm systems to get that to whoever needs to make that decision. And we try and have this less than 24 hours turnaround time for the data. And generally speaking, that's true. Sometimes there's a little bit of iteration with the operator in terms of you're changing different views, but again, that's normal practice. So the key thing here is the software must be simple to use. It's got to be intuitive, and historically it hasn't. So that was our one of our prime objectives, and that was particularly true for DAS data, because we had these enormous data files that were being gathered, terabytes and terabytes of data for actually quite modest duration surveys. And so what we've done is we've built a piece of software called HotDAS that will take these raw data files and strip out the frequency bands of interest, and that reduces the size of that raw data by about between 500 and 600 fold. And so you've now got a file that you can ship through normal comms system. We've got I'm actually quite keen that we have both DAS and DTS recorded at the same time, because these two measurements are often complementary, and so it's a very powerful thing to have. But we would seldom run a fiber survey on its own. We would always want to have some form of sensor package, a traditional sensor package at the bottom of the wire or the cable. And if it's a SLICKLINE system with no copper in the core within the SLICKLINE itself, then you're into memory gauges. So memory, pressure, temperature, gamma, CCL, those sorts of things. And so any software has to be able to cope with that type of information as well, and all the static information that you're gathering or is available in the well about the completion, the casing, and the geological data. So we do want to try and get this software so that we're pulling all of that into a single piece of software, a single application, to make life a lot easier for operators and server companies alike, and that is called QuickView. And so we'll have a look at both of these. So HotDAS, what does it do? So we take a raw data file, might be of the order of 2 terabytes in size, 2.5 terabytes in size, and push that through a Fourier transform, and we end up with you know, a few hundred megabytes worth of data once it's been decimated, and that can be pushed down comm systems to the end user if the end user is remote to the well site. The other thing is it's a two-stage process. So the first one is to generate this smaller decimated file, and then generate images from that that you can look at and start making interpretations on. And that two-stage process can happen at the rig site. And so the fellow at the rig site can look at these files and you know, have a discussion with whoever is the company rep on site, or take this file and push that through to somebody who can again recreate these images in a remote location. How hard is it to do that? Well, if you on the left here, the simplest is to select where are the raw data files, where would you like the product to go, and hit process and generate, and that is it. And so what it'll do, it'll take default settings for the frequency bands and the various temporal and spatial settings that we use and apply those. And so as long as an operator on site can browse to the location, then you will be able to generate a comprehensive set of information from that. It's as easy as that. If you wanted to get a little bit more ambitious, the most complicated it gets is on the right, where you can specify the frequency bands that you're interested in, put in some spatial and temporal settings that adjust how the image is created, and you again browse to the raw data file, browse to where you want the results to go, and hit process and generate. The software can work on a variety of different units. So while we use AP sensing and AP sensing units for DAS, we have used other units as well. And built into the system is the ability to automatically recognize which manufacturer's unit was used to gather the raw data, so it understands the structure of the file and then pull it in and process it. And so it takes away any issues about HDF5 format or FDS format or whatever format it happened to be from whichever vendor. It just simplifies the whole thing. And then we go into Quick View. So we've generated a whole pile of images and we want to start pulling all this information together. And so the point of Quick View is to, on a single application, to incorporate all the information you need to make decisions on that well. And this is where we could either look at a really dull and static image here, or we can flip onto live demo. So I'm going to suggest that we pull out of the slide here, and I'll flip to a live demo if I can. Let's see, where do we get to my live demo? Share this one. Right. So somebody interrupt me if you're not seeing a blank quick view screen. No interruptions, therefore I'm assuming you can see. Yeah. So what we've got is okay, yeah, we can all see, right. We've got an application which I've got a whole, I can select whatever project I want. I've got loads of different projects here, and you know, right now we're in an example well. I could import hotdas files, DTS files, and again it could be from any one of a number of different manufacturers' DTS unit. If it's a unit that we haven't experienced before, then we'd need a sample of the data from that unit so that we can then build the appropriate adapter so that we can just pull in that data. And then we've got a LAS loader, and literally as we speak, the DLIS loader is also in progress. So everybody's got some notion of geological information, so I know my geology. So here's the geological information from this particular well. I could have other things, photos or whatever loaded in here too. But we also may have casing points, and we've got completion elements. So safety valves, side pocket mandrels, hangers, etc. So we want to make this as easy as possible for the end user. This data can be preloaded and saved to the database before you go out onto the well site. And so the operator will have a completion diagram or a well composite log where all of this information can be gleaned beforehand. As I said before, we tend to run these logs run these surveys with some form of sensor at the bottom. So here we've got a gamma ray. So there's my gamma ray. I've got a CCL, and I've got temperature, memory, and memory pressure. And so it shows you that we're pulling in a whole range of different data types, and on this occasion I don't really like this here. I want my gamma and CCL together, so what I'll do is I'll just get rid of that, select that, double click, and it's on. So it's a very point and click, very user friendly. I can expand this out. I can zoom in and zoom out. So it's all the usual things that you would expect in a package. So if I highlight this this little track, then I've got access to, I don't like a green gamma ray, I want a red one, or all the usual, I want a solid line, a dashed line, etc., etc. Now we start to run into, because I'm running from a laptop, acreage issues, and so I'm going to get rid of some of these tracks just to give me a little bit of space. Now, the very first thing that we're going to do is we want to have a look at our, get rid of that one too, my DTS data. So this is a set of DTS data, which if you were the operator for the well and you were presented with this, it's pretty dull. It's not very exciting. You'll probably see that we've got seawater here. So this is an offshore installation, and so we've got nice cold seawater sitting at the top, and then we hit the seabed, and then we go down and it gets hotter, and other than that it's really dull and unexciting, and so nobody gets any prizes for that one. But what I want to do is to extract from this DTS data that we've acquired some proper information. So I'm going to clone this track. So that's just a complete clone of that track, just so you can see what the heck's going on here. And I'll squish this one up a little bit. And now I want to change the view. I want to, instead of presenting absolute data, I want to present relative difference from the first trace in the well. And that's a bit more interesting. So let's just change the contrast a bit. So now we've changed the scale to -2 to +2, hit apply. Now I'm seeing stuff, and that's starting to look a bit more interesting. So we can see there's something here, you can see this feature here, and you know, out of curiosity, what is that feature? So we've selected the track gradient. I want a new gradient for that. So that is moving up the well at 0.13 meters per second. That's an interesting bit of information. And I could keep annotating this with more of those if I wanted to, but just for, I can see time is marching on. So let's clone the track again. No. So we've cloned the track again, and this time I want a different view. I want to have a look at a successive time difference. Oops, move that out of the way. And so all we're doing is from each adjacent trace, what is the temperature difference? And we can still see the faint outline of this, but now we're seeing these other features. There's a leak up here that's coming down the way. And if we zoom in on that, yeah, just to show, yeah, there's definitely something there. And we can also do things like split the well into different time periods. So in this well, this period here is the baseline, and then we bled off annulus pressure. And so if I wanted to, I can then look at stacking all these profiles. So let's clone the track yet again. And now what we want to do is to do a differential log. Yeah. So all I've done is taken all of these traces, stacked them together, and all of a sudden I've gone from actually quite a dull thermal profile in this track, which is so dull I'm going to get rid of it, so I don't care about that one anymore, to these. These are looking more interesting. Now I want to add into this track some completion elements, and I'll put in a cursor, and that side pocket mandrel at the bottom is looking pretty suspicious to me. So we've got a massive spike here. We've got this thermal response once we start the bleed process, and we've got fluids moving up the way. So you know that the client wanted to know where is the annular leak in the well, and side pocket mandrel number 2 is the cause of that leak. This particular well, it was swapped out, production was restored to the well, everybody was happy. However, you got an issue up here at the top of the Lark formation, and you've got an issue up here as well. So there's a number of other problems in this well. So let's pull in some of our acoustic data. So this has just been temperature. So I'm going to take, yep, fine. I'm going to take this DAS data, add it, not to there, I'm going to add it to the end here. So here's my DAS data. And there's all sorts of activity going on. So let's just again create a little bit more space. Pull this out a little bit. Now remember, we had a number of different frequency bands, a number of different spatial and temporal resolution settings, and this is image number 1 of 198 images, because I've got lots of frequency bands and temporal and spatial settings to choose from. So this is the 0 to 5 hertz band, and we can see all sorts of things going on here. And I can cycle. So this is the duration of the survey and the whole length of the well. And this is very responsive. So I can cycle through these frequency bands as easy as that, just hitting that up and down arrow. And why does it make a difference? Because the frustrating thing I found with all the other applications where you get one view of the data, and yet there's lots more information hidden in the data. And so by allowing people to cycle through this, you can see how things are changing very, very quickly. So for instance, at that point there, again, you put on my little cursor, at that point, there is an event that's happening at this point in the acoustics and in the temperature, and it's just at that Lark formation boundary. So there is absolutely an issue there. We can also see when they lined up the well to the flow and cracked open that annulus, we get a little spurt of bubbles moving up that annulus as they just cracked open the valve, and then they didn't actually open it up fully until they got to this point here in the well. But again, that's a really good confirmation from the DAS and the DTS data that side pocket mandrel was leaking. And again, with this, just get rid of that. With this particular trace, again, we can do exactly the same. We'll take here we go. I haven't done that exactly right. I mean, the times I've squished this one up, so that's why it looks steeper. This one is a bit, so the time scales are slightly different. But so again, this is moving up at 0.12 meters, 114 meters per second. So that's the same event. And so it's a really powerful tool, and I can keep adding to that. Here's another one there, and another one there. And I can see how these things are changing as we move to different frequency bands and different spatial settings. So I'm looking for my best quality image all the time. And it's as easy as that. If I don't like it, I can just ditch it, start again. And I can save this as an image. I can, again, zoom in, zoom out to get a better quality image. But that gives you some sort of idea on if a client wants to know what do you see in the data, and this tool pulls all the bits of information together, the log data, the completion, the geology, the casing, the DAS, the DTS, and it allows people to really get under the skin of the data as easily as possible. So I'm kind of conscious of time, so I'm going to move back to whichever application it was. Where's my, yeah, my PowerPoint. So is that not going to, yeah. Are you, no, I'm not, I'm still sharing that one. Why is that? Whoa. Yeah. Yeah, so I think that gives you a feel for how easy it is to get up and running with the hardware. We've tried to make it as easy as possible. Not to be concerned or worried about the software and the processing, because again, we've tried to make that as easy and simple as possible. And the turnaround time is quick as possible. So I'll see that we've only got about 7 minutes left. So I'm going to close there, stop sharing, and then allow for questions if there are any. Hopefully that's been informative. Stunned silence. Right, Natasha, if you can, I don't know who.
Yeah, I'm here. There is actually one question in Q&A section.
Is there?
Yeah, probably.
Okay, what does it say?
So the question is, how many extra people do I need on the well site beyond my usual wireline crew to run fiber surveys?
Oh, that would be, that's an easy one, because it's one. unless you've got a 24-hour operation, in which case it's two. What we've done is for other clients, we've trained up the guys that normally do their cased-hole production logging, cement logging, those sorts of things. Those guys are used to dealing with data, and so we will generally take those fellas, teach them how to use the acquisition units and the software, and they are very quick on the uptake because they're used to that sort of thing. And so it's the normal wireline crew. You just need one guy who's a fiber specialist who knows how to operate the units, connect and the fibers, and run the software.
Thank you. And there is another question in the chat. I think you can read it.
What is the working strength and breaking strength of the SLICKLINE? And
yeah, and then it's not.
What is the working and? Peter, go for it.
Yes. So with the heavy duty one, we go beyond 800 kilos braking strength. Of course, we are adding stick-wall tubing small OD before July this year. So we will be even improving the braking strength of our designs. And then we work on carbon fiber SLICKLINE, which will very likely go much beyond that. Thank you.
Yeah, I mean, the key thing here is to have sufficient strength so that we can put a reasonable sensor package at the bottom of the fiber. And the benefit there is with fiber, we can quickly survey the whole well and then zoom in on a specific interval of interest and get a more specific sensor package at the bottom of that wire directed to that particular interval. So quite often you hear about these acoustic tools. Halliburton and GoWell and Archer have got these really good point acoustic tools, but they're very slow to run, very time consuming. But if you knew where to point them to, you could really shorten that. Anyway, I notice there's another question here.
Mike,
Yeah.
let me give a little bit more information on the braking strengths and the working loads. I have that data right in front of me. So for fiber only, in a 125-inch diameter with 3.2 millimeters, the braking strength is 950 pounds and the working load is 570. To go to a larger size, 160, the braking strength is 1,300 pounds, and the operating recommended operating load is 800 pounds. Now, and those are fiber only. So then, if you go to copper and fiber, that comes in 160, and the braking strength is 1,270, and the working load is 760. However, if you really want to go heavy, we have a 180, 4.6 millimeters, where the braking strength is 3,550 pounds, and the working load is 2,130 pounds. And as you can imagine, as you go bigger and add more elements, then the price goes up. But the 125 with a couple of single modes and a multi-mode is pretty affordable product.
Yeah.
Okay, Mike?
Right. So there's another question here about are you running this software in Canada for production logging and abandonment? No, but we could do. So yeah, we've run it mostly in North Sea, and we've done used the software in other places in the world, but not specifically Canada. But
we do have a PIMP going to Canada, and I'm not at liberty to tell you who the end user is, but we have that's in production at the moment.
Okay, and then there's another one. Is the fiber optic cable any different from telecoms and sensing fiber cable? Yeah, now we've got to be careful here. So if we want the wire to last a reasonable length of time. So the whole point of having SLICKLINE enabled, fiber enabled SLICKLINE is I can share the cost of the capital cost over many, many wells. And so what we want to do is to make sure that the fiber has sufficient coating on it to protect it from the harsh environment in that well. And so there's a temperature issue in terms of it's not standard off-the-shelf telecom grade fiber, which is only good to, I think it's about 85 degrees C, whereas a lot of our wells, we're hundreds of degrees C. So we do specify both for the wire in terms of its metallurgy and the fiber in terms of its thermal and chemical resistance, a certain coating to make sure that we protect it. So it's not the same, but it is designed for that environment. The next one was pressure control equipment, and it is exactly the same. And that is the benefit. So I'm using the same SLICKLINE crews, the same pressure control equipment. There is no difference there whatsoever. And that's why you just need that one extra fella and that drum of wire to get up and running.
Yes.
And there is another question in Q&A. What is the maximum SLICKLINE. Sorry, there's chat coming. Okay. What is the maximum temperature of SLICKLINE and E-line with fiber, and what is maximum pressure?
Well, yeah. Okay, I guess go for it too, Peter, if you want to answer that one.
Well, with these downhole type of fibers, you can possibly go above 300 degrees, but this is really very rare. So I would classify the temperature range 180 degrees to 150 and 300.
And that's centigrade, Peter.
Yeah, that's always
Uh,
centigrade. Yes.
Yeah, our audience is probably mostly in imperial, so we're looking at 300 degrees F, 356 F, and then in the near future, 570 degrees F.
Yes. Yes. Thank you, Tom, for that.
Yeah,
And the pressure,
and I guess
normal.
we've got to remember that the really early days of fiber deployment in oil and gas was for steam floods, and so they actually originated in some pretty warm conditions, and then in terms of pressure, it's limited by the pressure kit that you've got. So.
Yeah. And the slick line is nominally rated at about 13,000 psi.
Yeah.
Now you can improve that by adding thicker walls, which means a larger diameter, but the normal ones are about 13,000 psi.
Yes, the wall thickness really helps on the pressure side, but it is also circularity of a design in which needs to be preserved into the production. So it's a OD, it's a wall thickness, and it's circularity in the production, which defines the maximum pressure rates for the slick line.
Yeah. There's a question about casing leaks service and DTS interrogators do they have to have 0.01 resolution? Now, we've got to be real careful with this, because this is where we boil it. It comes down to the longer I leave the data to stack, then the better the signal to noise ratio is, and the smaller that resolution is. And I think the manufacturers have, for each of these units, have specifications as to how the resolution changes with both distance and time of acquisition. And so you would look at the job and design the DTS unit, or have the settings for the DTS unit appropriate for what you're trying to measure. And so if you're looking at straight away for really small changes, then you have to have the refresh rate being a much longer to achieve that. But my personal preference is to have a downhole temperature sensor at the bottom of the fiber to calibrate against, and that's the most powerful way to do it. So with that data set, we didn't have time to go into it, but that downhole gauge that was at the bottom of that fiber, I can correct the DTS temperature to that bottom gauge temperature, and it really tightens up the resolution enormously. And then there's another question, which is how does one tie in the CCL to the log? So for the memory log, I think it was it might have been a probe system actually that was running that well from probe. And what we're doing is we're taking the CCL, it's the time depth conversion for the down pass and the up pass to create my depth logs from that. But because I've got a gamma CCL, I can tie in to the reference gamma ray from the composite log, and so that, I mean, that's That's really how we did it on that particular well.
Yes. There
Did
is
we
more.
perform jobs in 7-inch tubing in a gas production well? I'm not sure about 7-inch tubing, but generally it's been 4.5, 5.5-inch tubing. But 7-inch tubing wouldn't worry me any. In fact, gas is very easy to work with because the Joule-Thomson effect is really helping you out big time. So that wouldn't worry me in any way. Oh, here's another one. The coated E fiber cable with a conductor. What are the H2S and CO2 tolerances? That sounds like a wires and bytes question. So here you go, guys. A 7 kilopascal. So so we've got a partial pressure of H2S and CO2. Is it going to be okay for that? Well, I'm sure they'll be able to tell you.
Yeah, the outer layer of metal is Incaloy 825, and it's roughly equivalent to S77 alloy, which used on E-lines, 20% H2S. So I don't think there's any issue with that. It's
Yes.
standard cable is a stainless steel inner tube and an 825 alloy, Incaloy alloy outer tube. It'll withstand just about anything. If E-lines are using MP35, then we need to think about it. But other than that, this cable will work.
Yeah. And then the next one was, how can we test the line in order to verify its integrity for the next job? It is standard practice to run what they call an OTDR survey on the fiber to make sure that the fiber hasn't been damaged both before and at the end of a job. And as normal practice, we'd want to cut off the section of cable as per normal practice with SLICKLINE anyway. And then in terms of, is there a pinhole leak in the outer carcass to cause ingress into the inner tube? Again, there's pressure gauges on the system just to make sure that we're monitoring for that. And the ends are capped anyway and with epoxy so that there is no ingress to the ends. And then we've got a pressure chamber at the top of the wire as well. For the DAS integrator, what is the maximum frequency sampling in order to train all the effective acoustic information downhole? That depends on the unit that you use. So, and it has to be greater than 12 kilohertz. So if we had, generally it's a, there are 10 kilohertz units, there are 20 kilohertz units. And then for the maximum frequency for each one of those are half respectively. So that would be up to 10 kilohertz frequency for a 20 kilohertz unit. And so if you need 12 kilohertz, then you would have to go with in excess of 24 kilohertz pulsing to extract what you needed from that. But that's entirely the selection of the surface interrogation unit that controls that. And so you would use the appropriate vendor's unit in that case. I mean, while we've used AP sensing, we were quite happy to use anybody else's if AP sensing standard units are not appropriate for that particular application.
There's another question about the quick view application. Yeah. So sorry, there is chat. Can the quick view software make comparisons between you and historical surveys to give a time-lapse view?
Oh, that's a great question. I love that question.
It's from someone called John Davis, actually.
Oh, okay. Right. So it's a good prompt, John. the whole point of QuickView is we've got encased hole surveillance. You've got cupboards full of CDs, hard drives, or files on laptops all over the place with a whole bunch of data. And it's shocking the way we treat our data. So what we've done with QuickView is to have a data archive and storage facility. So once I've finished doing the analysis, I can save the image, and so I can recall that anytime I want. But for the next job in that well, I can pull in the new data and append it to the old data. So in other words, I can have the old survey that we did a year ago, 2 years ago, sat alongside the new survey as a direct comparison. And that's, so we're adding to the net knowledge in the well for the operator. And so this business about scrambling around for, oh, well, it's in a different format, it's in this cupboard or that cupboard, just doesn't arise. Yeah. What's this one? Do you have any examples of flowing versus shut-in DTS and DAS data that can be shared? Yes, I do. And in fact, what we tend to do is we always want to run a baseline static. So when we run into the well, we go as deep as possible, and then we just sit there for half an hour. And the purpose of that is to see what normal looks like, and then start either opening the well to flow or injecting into the well, and then doing that comparison. And so it's normal practice to do a static, then a flowing pass in the well, and then go back to a shut-in state so that we can see it return back to its normal state. So that's a very, very common thing to do.
I think there is
Any
another
others?
one. There is another one. Is there a minimum core diameter for the various cable diameters? And also, what is the minimum sheave diameter? So, I mean, with the present technology, which use laser welding, we can really go beyond, much beyond 4 millimeters OD. With the new line, the thick wall tubing line, we will be starting from 3.17 millimeters and wall thickness from 0.52 millimeters, and then we can increase to, I mean, over the 9 millimeters OD and wall thickness over 1.1 millimeter. The minimum sheave, I think this is important because the sheave, I would always use, the bigger the better, because that prolongs the lifetime of the slick line. So I would say the recommended is always like 40 times the diameter. That would be the recommended diameter of the sheave. And yes, Mike, do you want to add something to this?
No. I was just trying to look for the next batch of questions. Oh, yeah. Any other questions? We're 16 minutes over, but that's okay. I'm quite happy to chat about this for ages.
We still have 16 people online, and if they've got more questions,
Go for it.
Go for it. That's right.
Yeah, there is question in chat. You can see
Is there?
about for fiber itself for DTS logging. Can you see this question?
Oh, is it how easy to use are the DTS and DAS units? Is that it?
No, it's the last one in the chat for all panelists.
Oh, chat. Can you read it out? I'm not quite sure which one it is. Yeah, read out the question, Natasha, please.
So it's for fiber itself for DTS logging, 62.5 125 fiber is better, or 50 122 fiber is better?
Yes, these are the types of fibers. So.
Oh, right. Yeah.
Yes.
Okay, so for the clients that we've got at the moment, what they've tended to opt for are two single mode fibers, one for DTS and one for DAS. Now that's unusual because normally you would expect multi-mode fiber to be used for DTS, but multi-mode is more expensive, and therefore to keep costs down, and because we can get access to single mode interrogation units for DTS that are actually of comparable quality, then that's the way the clients have gone, because they've opted for the cheaper, more robust single mode fiber that it gives is a cheaper sticker price for them when they come to purchase the wire and the cable themselves. Now, if they wanted to include multi-mode, then that's not an issue, and really I don't really mind if they prefer multi-mode DTS. It just reflects in the price, yeah, and so it's like the specification on chemical resistance or temperature resistance, and you can specify quite a big thing, but then it just means that you've got a bigger cash outlay to start with. And a lot of people, when they start with fiber, they want as small an outlay as possible just to see how the market goes, and then if there's demand for a better or different service, then go for that later. Any other questions, Natasha?
Yeah, there is one for wires and bytes.
Is the E-coated E-line fiber cable capable of run through a grease injector, or will it damage the fiber? Well, I'm not sure about this one, so
Well, let me help you. The conductor is actually inside the outer tubes. You have the very center tube is the fiber optic with its own steel encapsulation, and then you have a layer of copper wires around that, and then insulation, and then your two layers of tube, stainless steel and Incoloy, or in the future a thick wall. And so the outer surface of the slick light is alloy 625. So absolutely, you can run it through grease injection, no problem. It will not
I think
the fiber.
Yeah, I think that question maybe somebody was thinking about the plastic coating
yes.
line. That
No,
and who else offers that
but on plastic coated lines for permanent installation?
in the.
No?
No, I think that's where that came from, is that somebody was thinking about the line that has the coating on it to give you some electrical continuity on the inner wire, but that's not what wires and bytes are offering. It's copper inside, and therefore it doesn't. It's not the same.
So the question was from Brian Cowan. Brian, you are unmuted, so if you'd like to clarify anything, you're welcome.
We were just looking at your website, and it looked like there was a coated line for E-line, and we're just wondering if that was capable of running through a grease injector. We'd be dealing with wells with potential, 10,000 psi. So would we would probably require a grease injector, crack monitoring.
Peter, Brian is probably asking a cable which is similar, like compo check.
Oh, but there's another class of the cables. These are the polymer coated cables.
Yeah.
Well, so this is another. It's much bigger design actually, and our slick lines are not coated with polymer.
I was referring to your E-line.
Just
cables.
you're talking about braided cable, just standard.
That's right. That's
Yeah,
right.
it was the braided cable of the in-cab optical braided cable. To all intents and purposes, looks like a standard 5/16 or whatever standard E-line cable. So, as Tom said, you can use the standard grease injection sealing system for the E-line optical product, well, the optical product with the braided cable.
Okay, well yeah, we can proceed further down the road when we have.
Yeah, what we've tried to do is make both cables compatible with all the standard E-line logging equipment and SLICKLINE equipment out there. You know, one thing the industry doesn't want to do is go and buy a lot more new pressure control equipment for cables. So the whole purpose of this was to try and utilize existing winches and pressure control equipment for both E-line, the braided cable and the SLICKLINE.
Exactly. Similar for pump down operations, E-line pump down operations where, we're being able to avoid using the large, pressure control equipment, and then just go with a pack off type scenario.
Exactly the same technology.
Yes, definitely would like to move that way.
And then there's a question about, does line stretch cause any signal degradation? And the answer to that one is no, because there is overstuffing of the fiber into the metal jacket just to accommodate that. And that's a very common standard practice.
So it's always the fiber is always longer than the physical slick line. It's actually it's a 0.5% longer. That depends on the temperature, of course, and that can be adjusted in the design. Of course.
Any other questions?
Hello, Mike. Can I ask a question? Can you hear me?
Yeah. Go for it. Go for it.
Okay. My friend told me for judge if that interrogator could be used for fiber logging. A simple way is to play our music nearby the fiber. If the DAS interrogator could replay the music without any music distortion, means this is a good quality DAS for fiber logging. Is this true?
Now, what I have done is to take my iPhone, and I've got a little frequency generator on my iPhone, and then I set it to something, and then just lay it close to the fiber and make sure I can replicate that signal. But in terms of the type and style of music, no, I haven't done that, but I'm sure you could if you wanted to. But no, and I have seen demonstrations where some companies have put a specific soundtrack in a box with the fiber, and then played it back. But I've never done it. I've just used a plain. I guess I'm just dull. I'm just done a normal.
Thank you. If you use your mobile phone generating a certain frequency signal and use the DAS to receive that, what is the maximum frequency you're generating by your mobile phone?
I must admit, the only thing I've done that with is for generating audible frequencies, and that's merely because I actually want to hear my phone do it. And so when I go below audible range, and because I'm old, then my lower threshold and upper threshold audible is a bit narrower than if you're at the younger end of the spectrum. And so I've tended to go with, I don't know, 60, 70 hertz all the way up to about 500 hertz because I can hear it. But when you've got the thing set so it's too low for me to hear or too high for me to hear, I don't even know if the thing's on. So,
Okay.
so
Okay. Thank you very much. Yeah.
Any other questions?
There are no any in Q&A section.
Okay.
All right, well, this is Tom again. I would like to thank you for attending our webinar today. And our marketing group will be emailing you a survey, which you can use to rate the quality of this webinar and ask more questions if you think of them. And also, there's an option to sign up for our newsletter. So hopefully you'll do that, and we can keep you posted with the latest developments in this area. I encourage you to contact myself or James Stevens by phone or email if you would like to discuss the next steps or any particulars that weren't covered, and we'd be more than happy to help you. So thanks again, and be safe.
Okay, thank you.
Thank you.
Thank you. Thank you very much, Mike.
You're welcome.